These are the notes on exothermic versus endothermic reactions. Depending on who your teacher is, your notes might have a couple of other things or a couple of slides that mine don't have, based on if in class your teacher was talking more about the hot hands and the ice pack activity that we did. So if there's a slide in your notes that I don't have, you should just be able to skip that slide and then find the one that I'm talking about. All right, so thermodynamics is the unit that we are starting. And we are going to be looking at this branch of chemistry that is concerned with quantities of heat that is released and absorbed during chemical reactions. And a key here is that we are looking at this with those chemical reactions. I might have a soda can sitting on my table, and so when I put my hand on it, there's going to be heat that is moving from my hand to the can, but there's not a chemical reaction. So we can still talk about that in terms of heat. What we're going to be looking at, though, is in chemical reactions. How is that heat energy released or absorbed? And what is the difference between temperature and heat? Well, temperature is used to measure the average amount of kinetic energy or heat in a system. Individual particles may have more or less kinetic energy, so we measure the average amount of kinetic energy present in an object, and that's what we call the temperature. If something has a higher temperature, it means that there is more kinetic energy. Those individual particles are moving faster. If something has a lower temperature, that means there's less kinetic energy, so those particles are moving slower. There's not as many collisions. And so while temperature is used to measure heat, when we say heat in thermodynamics, heat is talking about the flow or the movement of that thermal energy from one object to another. So if I put my hand on that can, if I have a pop can and I put my hand on it, that can is cold, so heat from my hand is going to flow into the can. And so it's that flow of energy. My body's temperature, heat energy is going to the can. When we're looking at this, we are surrounded by things. So we like to kind of focus on only the things that matter and only the things that we need to look at. And we do this by classifying things as their system and their surroundings. A system is defined, system is defined as a part of the universe on which you focus your attention. Everything else in the universe makes up the surroundings. And energy that moves from one object to another due to a temperature difference is called heat. So again, that movement of energy. The transfer of energy happens through collisions, with heat always flowing from hot objects to cold objects. So always flowing from hot to cold. This is based on the first law of thermodynamics. Energy cannot be created or destroyed. It can only be converted from one form to another. And heat is conserved, meaning that it's not going to disappear or leave. It just might go to something else. So leaving one object in the system to go to another. So when we were looking at that hot hands ice pack, the chemical reaction in the packet was our system, and our hand and the air in the room were the surroundings. And while we drew kind of our pictures in class, if you had, here's my picture of, this is my hand, and maybe this is my ice pack. Well, if my hand is warmer than the ice pack, the heat is going to move from the hot object to the cold object, so that's going to move from my hand into the ice pack. With that, we could tell that that ice pack got colder because we can feel that heat energy leaving our hand and going into the ice pack, because that ice pack had that cold reaction inside. And so we were using our hand kind of to measure what was happening. And in that case, though, that ice pack and the reaction inside is our system, what we were focusing on. Heat transfers through molecules. And that's not really something that we can see. So this picture is going to have us looking at that on that really small microscopic level, just so that we can kind of understand how that's happening. The molecules contain kinetic energy because they have some sort of temperature, so they're moving. And when those molecules collide, some of that energy is transferred between the molecules. So if we look at this picture here, conservation of energy, you've probably talked about this in some of your other science classes, that during any chemical or physical process, the energy of the universe remains the same. So the amount of energy we have is the same, but that energy can get moved from one thing to another. And so if the energy of the system is increasing, it must have come from its surroundings. And so what we have here is a picture, and if you want to think of this, the system, this could be like our ice pack, but in this case we have that actual reaction or that substance in here. That's our system. This just looks like some solution. And then we have our surroundings. So a flame causes faster motion of air molecules. Air molecules collide with the glass, and then the collisions increase the vibrational energy of the glass molecules. So we can see the faster air particles are going to hit the glass. Then inside of there, those glass particles are vibrating, and then those vibrating particles are going to hit what's inside of that Erlenmeyer flask, that green solution. So the molecules of liquid in the flask move faster after colliding with the glass because they obtain some of its vibrational energy. And so that's how heat is transferred. We're not going to be drawing this on this level, but it's just important for us to understand how that happens. All right, so when we're looking at classifying our reactions, we have endothermic reactions and we have exothermic reactions. And we classify that based on where is heat in the reaction. Because again, thinking back to our definition of thermodynamics, we are looking at how heat is released or absorbed during those chemical reactions. So in an exothermic reaction, heat or energy is released by a chemical reaction, meaning that heat is going to exit or be a product of our reaction. Remember, we have our products on the right side of our arrow. We have our reactants on the left side. And then the arrows showing how we separate those out. So in an exothermic reaction, that heat is getting released. And so if we look at our example of an exothermic reaction, we see this purple triangle, which is the symbol for heat, on the right side of the reaction. In an endothermic reaction, heat or energy is required for a chemical reaction to occur. So heat is a reactant. It is something that is involved in those reactants. So we're going to see in an endothermic reaction that delta, that triangle that is the symbol for heat, is on the left side. So our exothermic example, we have that H2O2 plus O2 plus H2O2, and then that produces O2 plus H2O plus heat. So heat is a product, it is released or it is leaving that chemical reaction. In my endothermic example, I've got C2H4O2 plus NaHCO3, and I have heat as a reactant. It is what is helping to start that reaction, and then I get my products over here on the right. So endothermic versus exothermic reactions. So energy of a reaction, all chemical reactions require some energy in order for them to happen or to occur. We have those different molecules and chemical bonds require energy in order to break apart. And so those bonds release energy when they are created. So energy is required to break apart, and when bonds are formed, energy is released. So depending on the reaction, the process may overall release or absorb energy, and the energy released or absorbed in a reaction, we call that the enthalpy of reaction. And we use the variable delta H for that. So in an exothermic reaction, our heat or energy is released. So because that energy is released by our chemical reaction, our delta H is going to be a negative number. In an endothermic reaction, because heat or energy is required for that chemical reaction to occur, our delta H is going to be a positive number. And we will look at how we are calculating those later. That's not what we're worried about today. So this is just a nice summary for us to kind of go through and put all of that information together. So enthalpy of reaction summary. So highlight the appropriate answer for each question. So exothermic, and again, I always try to remember exo means exit. So energy is going to flow out of the system. Endothermic, energy is going to flow in to the system. And then as we look at the rest of these under our exothermic, so again, exo, that heat is being released, our energy is going to flow out of the system. Heat is released, leaving the system. And so if it's leaving, that means that our heat is a product. We'll see it on the right side of our reaction. And delta H is going to be negative. In an endothermic reaction, that energy is going to flow into the system, meaning that that energy is absorbed. Heat is a reactant. So we'll see it on the left side of our reaction, and our delta H is going to be a positive number. So factors that affect the amount of heat. So just kind of thinking back to this, I'm not going to go through this slide, but thinking of that activity and how you did that, feel free to touch base with a classmate or your teacher if you have more questions on this slide. Thinking back to that hot hands and ice pack activity, we had one thing that was hot when that reaction occurred, one thing that was cold, and so we had an example of both our endothermic and exothermic. So that hot hands chemical equation, so in the reaction below, we're going to write our heat, our delta symbol, that triangle, on the appropriate side, whether it's a reactant or a product, and then we're going to fill in if the reaction is endothermic or exothermic. So that hot hands chemical equation, it felt hot, which meant that heat was exiting the system. So then that is going to be exothermic. And if heat is exiting, that means that heat is a product. And so I'm going to put on the right side with my products, I'm going to put plus and then a triangle to show that's where heat was. Heat was a product. That instant ice pack, if it feels cold, that means that heat is going into the ice pack. That's going to be an endothermic reaction. And so heat is a reactant. We need the heat of someone's hand or something in order for that reaction to occur. And so our plus with the triangle is going to go on the left side of our reaction with our reactants. All right. There is an exothermic and endothermic check-in on Schoology for you to complete. Please do that and see your teacher with any questions.